We worry about global conflicts, climate crises, and our daily human struggles. But to understand what this blue planet is really capable of enduring, we have to look past the modern world. Rewind 4.6 billion years. The Earth you know is gone. In its place is a young, turbulent sun, burning 30% dimmer than it does today. Surrounding this young star is a protoplanetary disk, a massive, swirling field of dust and rock. This is the raw material of our solar system, drifting in the void, waiting for gravity to pull these microscopic fragments together into something solid. The stable ground beneath our feet did not simply appear. It is the result of millions of years of brutal cosmic construction. Eventually, that drifting rock coalesced into a sphere, but it was suffocated by a toxic methane atmosphere. There is no oxygen here. Instead, the entire surface is a rolling ocean of liquid rock, boiling at over 2,200 degrees Fahrenheit. To make matters worse, the young planet is stuck in a heavy shooting gallery. Local asteroids and massive boulders constantly plummet from the sky, crashing directly down into these rivers of boiling liquid fire. Under this constant bombardment, the crust cannot solidify. The planet is locked in a molten, hostile state, a glowing ember suspended in the darkness. At this rate, the surface would remain liquid indefinitely. It was a hellscape with no inherent way to cool down. Change arrived as a rogue, Mars-sized planet named Theia, hurtling directly toward the young Earth at over 9 miles per second. The resulting collision nearly tore our planet apart. The impact's sheer kinetic energy instantly vaporized billions of tons of rock, blasting it into space. Gravity quickly took hold of the wreckage. The superheated debris organized into a massive ring system. Over a short period, orbital mechanics swept the spelt together, condensing the fragments into a single glowing sphere. The most violent collision in our planet's history provided the mechanical process necessary to forge our closest companion, the Moon. In its infancy, this new moon was incredibly close to Earth. Its intense gravitational pull whipped the magma oceans into 100-foot-tall tidal waves, while the Earth itself spun so fast that a single day lasted only 6 hours. But as the moon slowly drifted further out into space, its gravitational drag acted as a brake. Earth's rotation slowed down, the immense tides subsided, and the magma ocean finally had the chance to cool into a solid, rocky crust. While Earth's crust began to firm, its future was being shaped millions of miles away by the gravitational influence of Jupiter and Saturn. These immense worlds were not stationary, they were migrating, gradually shifting their massive orbits through the outer reaches of our stellar neighborhood. As they moved, their combined gravity created a chaotic wake, ripping through fields of distant asteroids and comets. They violently slingshotted that icy debris inward, directly toward the rocky inner planets. The invisible gravitational clockwork of these distant giants was actively dictating the physical fate of our local planetary system. This incoming swarm triggered the late Heavy Bombardment, a period when displaced space rocks rained relentlessly on Earth and its neighbors. You can still see the permanent physical evidence of this barrage right now. The dark, sprawling impact craters etched into the surface of our moon are the direct scars of this exact event. For Earth, this barrage brought a critical resource. Many of these comets were dirty cosmic snowballs carrying payloads of water, depositing them directly onto the newly hardened crust. These impacts provided the primary delivery mechanism for Earth's water, supplying the foundational ingredient for biology. As this ice hit the blistering surface of the young Earth, it immediately flash-boiled into thick, heavy clouds of steam. This atmospheric buildup eventually broke, triggering millennia of non-stop torrential rain. When the skies cleared, the planet was transformed. It was now a dark, violent, and completely global water world with no land masses, trapped beneath a suffocating methane sky. The solid ground you walk on, the 24 hours in your day, and every single drop of water in our oceans are the direct results of this ancient, violent process. By surviving this era of bombardment and collision, Earth had transitioned from a molten inferno to a world of liquid water and solid rock. the physical environment where life could finally emerge.